Good afternoon, everyone, and welcome to the Construct Innovate webinar series on innovation and entrepreneurship. My name is Jamie Goggins, and I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. We're delighted to be hosting this five-part webinar series on innovation and entrepreneurship. This is our second week of the webinar series, and this week we're going to focus on software supporting innovation. So as I said, it's a five-part webinar series. If you missed the previous webinar in this series, which was on inspiring stories from leading entrepreneurs, then you can watch that back on the Construct Innovate YouTube channel. We're also recording the webinar today, which will be available afterwards, excluding the Q&A session afterwards. So the presentations will be available on the Construct Innovate YouTube channel to watch afterwards. And if you haven't registered for the upcoming webinars over the next number of weeks on innovation from the policy perspective, research to market, and breaking the silos, then please do register through the Construct Innovate website. You will find the webinars there. And all the webinars from the previous webinar series as well are also available on the Construct Innovate website. If you go in there, you'll be able to find them. So delighted to have two fantastic speakers today. Going to talk to us about software supporting innovation. So we have James Harkin, who's Chief Architect on Software and AI, and he works at the Irish Centre for High-End Computing, or ICHEC for short, and he's going to talk about software eating the world again. So how AI is reshaping software, science, and industry. We have Jennifer Cox, who's Director for Ireland of Women in Cybersecurity and also Solutions Engineering Director at TIMS. She's going to talk about addressing security risks and automation. So we'll have our two presentations followed by the Q&A afterwards. If you have any questions for any of our presenters, then please do post them in the Q&A function at the bottom of the screen. So put them in the Q&A function rather than the chat function, please. It's much easier. And then we can deal with those questions at the very end. So without further ado, I'm going to hand over to our first speaker, James Harkin, who is Chief Architect in in Software and AI at ICHEC, the Irish Centre for High-End Computing. So over to you, James.
Thanks, Jamie. I will share my screen. Okay. All right. Thanks, Jamie. Thanks for the invitation to speak today. Thanks to yourself and Kasia. I am going to give a quick introduction to myself, and then I'm going to talk mainly about software and AI in particular. You'll notice from my background here, I don't come from the construction industry, so my background is more tech than construction. But yeah, I'll talk about how software is changing and how AI is kind of impacting a lot of the software industry and how it's changing the pace of innovation in some ways. So yeah, quick kind of run through. I'm a kind of physics graduate from the University of Galway. I've worked on a number of different software roles over the years. I co-founded a software startup, ran that for about 7 years. I went on to be the chief data officer of one of the fastest growing sports companies in the UK. That was fun. And I'm now the chief architect at ICHEC, as Jamie mentioned. A few numbers there on the right. The number one is looking a bit lonely there. I was featured in Gartner once. You can tell I'm holding out for that second feature, but hasn't come up so far. So before we get into the serious stuff, one topic which consumes the internet, huge amount of bandwidth used by it every year. And it has been like this since the dawn of the internet. And I'm sure some of you are already guessing it is cat videos. And now we have AI, and it's kind of, I'm not sure whether it's funny or concerning that, you know, one of these pinnacles of human achievement is being mostly used to generate videos of cats playing drums and bits and pieces. But it is being used for good things too. So I'm going to talk a bit about like some of the history. A lot of people think AI is quite new, but it's been around a long time. This is just a sample timeline, a few kind of events that I think are of interest. As far back as 2006, antenna, so radio frequency antenna design, something that we do have the science for, we have the equations, we understand how to work them, but they're very complicated, and our designs for antennae over the decades hadn't changed much because of the complication in how to solve these kind of electromagnetic equations. So scientists working with NASA used AI, something called a genetic algorithm, it's quite different to modern day AI, but still an AI technique, to come up with kind of new generations of antennae in very quick kind of succession. It kind of generates, it's called genetic algorithm because you take a family of solutions and you kind of evolve them over time. And it came up with these designs for antennae that were radically different from what we had before, really strange shapes, things that we would never have kind of predicted ourselves. And these designs outperformed our human designs. So it's kind of an early example of AI really augmenting the output of what humans were able to do to date. And there are other examples of that with chip design, things like that more recently. But anyway, that was kind of a big moment. 2016, 10 years later, AlphaGo. Some of you may be familiar. Go is a game, much more complicated than chess. And like computers were already, they had already kind of beaten the chess grandmasters at chess, but Go is considered a much more complicated game. And at the time, it was assumed that AI would never be able to beat the human kind of champion, the world champion. His name was Lee Sedol at the time. There was a very famous match between him and this AI system, AlphaGo. I think three or five games in total for the match. They won a couple each, but ultimately it was the AI system that beat the human champion. It was a big kind of momentous occasion at the time. And during the games, like the AI did, like I think it's called Move 47, it's quite famous. AI did something, it made a move that shocked all the commentators, shocked all the human experts. They were all kind of looking at this move going, what is that? No human would ever make that move. But it went on to kind of beat Lee Sedol in that game. And there was a lot of back and forward, but AI did win. So that was a kind of a big seminal moment for AI again. Fast forward to 2020, AlphaFold, drug discovery for humans. Like finding a drug that works depends a lot on knowing the exact 3D shape of a protein. And I think it took decades for humans to discover like a handful of protein shapes. So really painstaking laboratory work, a lot of work went into it. And then in 2020, AlphaFold is an AI system which predicts the 3D shape of human proteins to unbelievable accuracy. And it did it, I think, initially for 20,000 human proteins in one go. At this point, I think it has predicted 200 million plant and animal and human proteins. So huge contribution to medical science. They won the Nobel Prize subsequently, recently enough, actually. So kind of a huge contribution to medical science and a very good example of AI augmenting what humans are already doing. So I'm kind of giving these examples to kind of show that AI does good things. It does get a lot of bad press. And then finally, LLMs. So we're in the kind of large language model era at the moment. Generative AI has exploded into mainstream. It's kind of followed a path that nobody could have imagined, and it's reaching a point where it's achieved like mass consumer adoption, as opposed to some of these previous systems were quite specialized and quite bespoke. This is definitely achieving huge adoption. So if we look at that adoption, ChatGPT, I remember the first time somebody in public mentioned ChatGPT to me, and it was a cheesemonger. Just like the ubiquitous nature of ChatGPT and LLMs at the moment is kind of amazing. Looking at this middle figure here, as of February, I think this year, 900 million weekly active users. So that's 1 in 8 people on the planet using this weekly, and that's just ChatGPT. Like it's separate from Claude, Anthropic, Mistral, all the other ones. So yeah, huge adoption. Hard to think of a product that has been adopted so quickly by so many. So again, just to kind of reiterate the scale of what's going on with AI. In terms of its evolution from when it was first released, like a lot of people would have been familiar with, AI in terms of autocomplete, like finishing your sentence, or predictive text, these kind of simple interventions. It started like that. People were very kind of familiar with that. It has moved on to kind of assistance where AI is writing code like functions, for software engineering. It's explaining bugs. It's drafting documents. People are using it to draft and analyze documents. And now, like, we're very much in the agentic AI era, where it's kind of taking more and more of the process from humans and kind of doing it itself. So we have AI that is making plans, executing tests, like it checks its own progress. It moves through a plan kind of step by step, does this semi-autonomously, and the human in the loop is kind of there to express intent. And that's kind of, that's the point we're getting to. The human just expresses what they want and their intention, and AI will go and plan and build almost autonomously. So kind of a very different paradigm to what we're used to. Anthropic are one of the big labs producing kind of frontier AI models. And they said recently that 100% of their own code is now written by the AI that they've built. So they've stopped, like, most of their software engineers are reviewing and designing and managing, but they're not writing code anymore. It's all basically AI. And I suppose I'm making this point to drive home the kind of the shift in the pace of innovation. So once upon a time, particularly in the software domain, a product person might think of an idea, or a founder might think of an idea, and then a couple of software architects might come along and understand, break down how that idea turns into a technical product, what components are involved, how they should talk to each other. And then the architects would hand over to software engineers, usually a team of them, and they would go about kind of writing design docs and writing the software itself. And the whole process took, teams of people, and usually months, lots of months, to create even a minimum viable product. And like, we're now at a point where that kind of style of innovation is really changing. We're at a point now where a person with no technical expertise at all really can think of an idea, use AI to generate an architecture, a plan, get AI to generate all the code, have AI deploy that code to a cloud server, and you're talking about going from ideation to production service, sometimes in a day. Like, it can be as short as that. So really, that pace of innovation has changed, and that's kind of something that we're all grappling with. To be honest, it's hard to keep up. So yeah, we're kind of into this age of agentic AI, where teams of people and architects and software engineers are kind of or their efforts are being replaced by swarms of agents. And you can have an agent who is the architect, an agent who is writing the code, an agent doing tests, an agent writing documentation. All of this can be done by agents working more or less autonomously together. It's expected that the number of agents will outnumber the number of humans relatively soon, which is kind of shocking in its own way. OpenClaw is something that some of you may have heard of. It's only been released a couple of months, I guess. An Austrian software engineer developed it and released it. Caused absolute carnage and havoc on the world scene. Has since been hired by OpenAI, I think. But yeah, he created this system where, again, agents are kind of enabled to work autonomously. You tell the agent what kind of personality you want it to have, what kind of things you want it to focus on, and it will busy itself to do your tasks and integrate with your systems, etc. It caused a huge stir because it was kind of released in a Wild West kind of way, no security, no nothing, and there were horror stories of what happened initially when people connected it to their systems, their WhatsApps, their emails, etc. So kind of a little bit Wild West, but it will mature and it'll become probably an enterprise play, and something that is very powerful. These GitHub stars on the right here, some of you might be familiar with it, but GitHub is an open source repository for software, hugely popular, used by most of software developers in the world. And a star is a way of kind of endorsing a project, saying it's good. So it achieved like 247,000 GitHub stars in a short time, like weeks. I checked just before the presentation, the number is now 357,000 stars. So hugely popular, hugely influential, slightly Wild West, but will mature. And again, kind of changing the paradigm of how people get work done, I suppose, is the key message. One final crazy example, a company in Australia found a way to connect human brain cells to silicon. And they have a system now, I think they call it the CL1, where they have 200,000 human brain neurons running in a way that they're able to use AI to train these neurons to perform actions. And yeah, one of the things they were able to do was train it to play the computer game Doom, which is crazy. And it's obviously a kind of a bit of a marketing play, but they're just highlighting the fact that they've got an alternative technology, and they're inviting people to come and try applications on this kind of slightly scary interface between humans and machines, but very, very cool as well. So coming back down to reality a little bit more, and looking at the construction industry, like one of the key things about large language models is in the name, they're very good at language. So, looking at, and lots of domains are very dominated by documentation and regulation. So like documents can be analyzed, read, summarized very quickly and very easily by AI. Like the tools now are very good at doing this. Like even a year ago, they weren't as good. They're now excellent. So you can have a huge document summarized. You can have a Q&A session with a document where you just ask questions and look for details. You can have a document converted in, like if it's a huge document, you can have it converted into a 15-minute podcast between two people chatting away, like on a radio show. Listen to that on your way into work, on your commute. Amazing things you can kind of do to find alternative ways to consume information. Reading documents is a slow, laborious task, and there are kind of new ways to consume that information now. In terms of design, as I mentioned, like the kind of NASA antennas, like you can use multimodal models now. So multimodal models they can handle text, images, video, audio, both input and output, depending on the models. So you can use these models to generate images, generate designs, iterate on designs, remove things from images, all kinds of kind of design tasks that you can do, again, without any real level of expertise in images or video, etc. So a kind of a big acceleration in terms of what you can do in terms of output. Planning and compliance. I've worked in a couple of regulated industries in the past, and again, sometimes understanding regulations and the impact of compliance can be a task in itself. And again, like LLMs are so well equipped to digest huge bodies of text, to understand them, to summarize them, to explain them, to check off lists, so there's a lot you can do in terms of, again, accelerating workflows for some of the tasks within a business. And finally, kind of operations. Like a lot of people, when they think about AI, they're thinking, how can I build AI into my product or into my service? And that is, of course, something of great interest, but it's also something you build into your workplace. So scheduling, calendar invites are notorious. Like everyone has meeting overload, and trying to get 10 people's calendars synchronized. You can use agents for that now. Meetings themselves, you can have AI summarize, like listen to the meeting, take notes, produce minutes, follow up with action items. I use a system internally which it'll take notes, but it'll create a list of action items for each person at the end of a meeting, which again is just accelerating my own personal workflow. It's a task I don't have to do. So there's a lot you can do within the workplace in terms of accelerating your own workflow, and then there's a lot you can do with your products. On the topic of products, I had the pleasure of meeting Donna from Altair last year, and it's an example of an Irish company using all of these kind of latest and greatest AI techniques, specifically for the construction industry, for the tendering process. I don't know the product in detail, and I'm not going to speak for Donna, but I know that he uses AI to ingest image data from tenders, to ingest text data. He's able to kind of, or the product is able to kind of look at the bill of materials, look at designs, look at the tendering process, and kind of identify weaknesses or identify gaps, and overall just speed up the tendering process. So I think Donna is actually a member of Construct Innovate, so you can feel free to reach out to him to get more details on the product. But it's nice to see an Irish company using very cutting edge AI for specifically for the construction industry. I'm kind of coming to the end of my slides, but literally in the last few days there was another big change, and this kind of expresses how quickly these things change, or how quickly this industry is moving. So in the last I think week or a few days, Anthropic, again one of the big AI labs, they discovered, I guess, or they developed a new model called Claude Mythos, and they chose not to release it. So on the left-hand side, the negative aspect of the story is that, like, this software or this AI model that they developed was so adept at discovering security vulnerabilities that it discovered thousands of security flaws in every major operating system and platform that we use across the world. So, like, kind of frightening in some ways. Even this 27-year-old OpenBSD bug. So OpenBSD is an operating system that has been open source for decades. By nature of the fact that it's open source, like, thousands of contributors have reviewed it, have fixed bugs, have made contributions and made it better over time. It's widely regarded as the most secure operating system. And even so, 27 years of human reviewers, thousands of people involved, millions of tests run against it. And even so, this latest model found a security vulnerability that, let's face it, humans were never going to find at this point. So Claude took the somewhat responsible decision of not releasing it to the public, because hackers everywhere would have just infiltrated every system. They created a new project, Glasswing. They invited the 12 kind of top software companies in the world to, they've shared the model with them to kind of get ahead of the fallout. Because if one company have discovered this, then it won't be long before others follow. So yeah, like, cybersecurity is in for a kind of rough ride, I would say, in the coming year. On the positive side of the story, this model, Claude Mythos, they didn't develop it in order to find security vulnerabilities. They just developed it in order to be good at coding. And SWE bench is a kind of, it's a benchmark that people use to measure the performance of AI systems against software tasks. And the previous best was 76%. And, like, the improvements that tended to happen with each generation of AI model were small, like 0.5%, 1%, and it was creeping up to 76. This latest one is at almost 94%, enormous jump. And kind of really is a turning point. Like, it's really kind of capturing the fact that at this point, AI is better than humans at software engineering. Like, I think this is a one-way ticket. It's clear that AI is now outperforming the vast majority of humans at software engineering tasks. And that's kind of here to stay, I would say. So really going back to the story of the kind of pace of innovation, it really is democratizing in some ways, that people without tech experience can become creators. They can develop products, they can launch them, they can do this at a pace that was never before achievable. So positive and negative aspects to this latest development, but good to be aware of it. And yeah, we're all kind of grappling to keep up and kind of deal with these changes. Final slide, a bit of a plug, I suppose. ICHEC, so the Irish Centre for High-End Computing, we won 2 kind of national and European tenders in the last year. One is the Caspir supercomputer. This is going to be Ireland's next supercomputer. It'll come online mid next year, and it's there for public sector usage, also for private sector. It's there for science. It's there for innovation. It's a huge supercomputer, a lot of GPUs, a lot of AI compute possible. And it's generally subsidized and kind of there for scientific purposes. So that is available, or will be available. And the AI Factory Antenna is a co-funded project from the EU and from DFERIS here in Ireland, to the tune of 10 million. And it's focused on getting AI infrastructure available for SMEs and startups and public sector. Primarily making the infrastructure available, but also offering supports and knowledge transfer for people to kind of get on board with AI or develop an AI model or improve existing models. So all of those things are available, and you can get in touch if any of those are of interest. And that is it. I leave you with a slightly cheesy quote that you've all seen before, but it's very true of AI. Like it's kind of, it's not going anywhere. There's a lot of debate and a lot of mixed press about it, but it's here to stay in some form, and it is enabling new things and new paces of innovation that I think is important to kind of keep pace with. So yeah, thank you very much, and yeah, I'll stick around and I'm happy to answer questions.
Brilliant. Thanks a lot, James. That's a fantastic presentation. Just shows how quickly things change. I think this is our third year running this webinar series, and it's amazing how each year, each week, each month, things change. And sometimes we're going, is it that lack of awareness from my side or our side, or is it that things are changing so quickly? And you can see it's both. There's
Yeah.
lots of things there. So look, I've a lot of questions, a lot of things to discuss with you on that, because it's such a hot topic of space. So we'll save that for the Q&A session at the end. So I'm going to hand over to Jennifer. So Jennifer Cox is Director for Ireland of Women in Cybersecurity and Solutions Engineering Director at TENS. And she's going to talk about addressing security risks and automation. So over to you, Jennifer.
How are you? So just one second, I share my screen and make sure we're good. To the beginning, Jay. There we go. Now you see that okay?
Perfect, yeah.
Awesome. So yeah, my name is Jenny Cox. I go back there to the beginning actually. So I have been working in cybersecurity for 20 years. The last 10 of them specifically kind of in vulnerability management, and then in automation, and now AI and automation, just gel all those things together. Company I work for currently is Tynes. We do what we call intelligent workflows, which is basically the combination of using AI where you want to and automating all of the workflows that you already have. So the chances are there's a lot of things where you have manual processes for dipping in and out of software to identify how it's used, where assets exist, where you've got vulnerabilities. We help with the automation of all of that in all parts of the business, but we focus primarily on the security side of it, because we were born out of security as such. What I'm going to talk about today is covering a few of those things. So what's specific to the construction industry with regards to security challenges. And I love that James finished up his one on the security. And we actually didn't see each other's talks nor talk to each other about each other's talks beforehand, but that was like beautiful. Thank you, James. Leading straight into the security side of things. I'm then going to talk about the automation and AI. There's always people that will shy away from it, and something that we find in our conversations, certainly through work, and then even on the WISA side of things, I'll talk to people from lots of different industries, is there's a hesitation. There's those that are like, throw me off that cliff. I want to do everything AI, absolutely, all in every way possible. And then you'll have others that are a little bit more reserved. And often, typically in the security side of things, you'll see more reservation than most. I find my children, that generation, are like really reserved around using AI and what that means for them and their data, which is really interesting, because I know typically, or at least traditionally, it was the other way around. The younger generation is the one that embraces it all head on. But I love that they're asking questions, because it's forcing us to do better when it comes to creating product and making it clear to people how their data is being used and where there's risk. And then I'm going to cover a case study. So it will have real life examples, and it'll have a typical best case kind of case study example, but I will differentiate between the ideal and the real when I'm talking about both of those things then too. And what I will supply, I know we supply our slides for you to have a look at this stuff afterwards, but what I'll also supply is an additional sheet with references into all of the sources for any of the statistics and stuff that I'm going to talk about today. Sometimes, I don't know about you, but when I look at statistics, I get completely mind grabbed by one in particular and then forget to listen to everything else. But I also go, no, there's no way it's that. So I like to have the stats myself to support it. So with that today, I'll get into these 4 different figures to begin with, and then I'll talk about a few little more kind of figures from that. But these are the ones that grabbed me the most, because obviously, like, my background is actually in theatre studies and psychology, but I ended up in tech. Makes sense of that. And my closest connection to working directly in kind of in construction is I have a son who's doing aeronautical engineering at the moment with an aim to being into renewable energy when he's done. So whether we ever had anything in common or not, we spend a lot of time now talking about both the technology overlaps and then the engineering overlaps and the thought processes of all of those things, which is fascinating to me. So I really enjoy digging around and finding information, mapping this information to the industry and making it more relevant. So it's not all going to be doom and gloom stats. It's always like when we do presentations, we love to go, "Ooh, look at this big, fantastic, terrifying figure," but it's going to come with a solution at the end of it. So thanks so much for everybody for joining this. And hopefully if you have questions, drop them in as you go. Otherwise, we'll talk about it at the end. So what I wanted to talk about first is that in the construction industry, you have the unique perspective of having a lot of mobile assets naturally. Now, when we talk about other industries, we talk about those assets being things like mobile phones and iPads. Fair enough. In your case, it goes a hell of a lot further than that, especially in construction sites and stuff too, that your mobile assets can be things like your crane diggers, your generators, all of the big kit and caboodle as such there, and they're can be prime targets both for technical attacks and for physical risk then as well. So your industry typically faces those 31% more cyber attacks than an average industry. And like the first question you might ask there is like, why? Is it because as an industry is later to digitalization? Yes, but you're also not rushing into it. So you're not suffering the same traps and falls as other industries might be to begin with. So what those risks can mean for you, I know there was a site hack in Wexford last year from Wexford, of course, heard about that one. You're talking about remote shutdowns in the middle of a job. It's like it's the equivalent these days technically to leaving the keys in the cab of the vehicle, which I'm sure nobody does anymore. But when we talk about the digital side of it, that's the risk as such from here. So we're seeing more of those attacks within your industry. When it comes to the IoT devices on site, we're seeing over 300 million plus vulnerabilities globally. It might be hard to gauge that depending on one of you could be on this call and from a multi-billion-dollar business, another one could be from a small SME business. It's all relative. But what we're looking at are things like GPS trackers, telematics. They're all things that are really great for efficiency. But what we've learned in the cybersecurity industry that on average 75% of those devices remain completely unpatched. So when James was talking about the vulnerabilities that are identified by Anthropic, and whilst we don't have the information about that, what we're basically saying is something that somebody hasn't fixed yet, an open door somewhere. And we see in the construction industry, 75% of those that haven't been patched that are still outstanding. So hackers can do things like spoof signals, they can reroute fleets. We talk about chasing. Have you ever chased a ghost truck where you think it's going in one direction and it's not? That would be when your GPS trackers are either off by accident or in the event that somebody's able to hack them and make it look like they're going in a different direction. So if you take those on a 1-by-1, doesn't look too bad, it's manageable, but then multiply it on a cyber scale where it hits a whole fleet, it becomes much more of a headache, shall we say, from there. Then on the theft side of things, in the industry, it's costing $1 billion plus annually. And that means things like 20% of the equipment is in downtime on average. It's not just people smash and grab. Like I do remember many years ago, someone stealing a digger and breaking into an ATM machine and how, that was shocking, but that's long before any of the digitalization of these things. So it's not just smash and grab anymore. The cyber theft can disable the tracking and then you don't know where it is from there. So, in Ireland, where we essentially have a housing boom, we say at the moment, we're talking about 200 million plus euros that are lost annually within the industry because of theft on that side of it. And then the supply chain attacks that can be through vendor software. I know that everybody gets a bit nervous now because there's more responsibility on third party bodies. There's more responsibility on the individual business to take accountability for the third party vendors that you're either leasing equipment off of or using software tools from and such too. And understanding that when you don't have the visibility of it is challenging then too. So all of these risks are the kind of things that naturally are going to stifle innovation, and we're here about software being used for the innovation side of it. But if you look at automation, potentially you can flip that on its ass, as I would say I'm a house full of boys, so sorry, I'm probably a little bit more crude than most. Manual checks aren't going to cut it in this sense. And I'm sure that you've all felt the pain of manually dipping in and out of different tools and calling people and checking systems in order to understand where everything is at any given time. So if you're managing those assets that are all over the place, like literally all over the place, we're talking about machinery, vehicles, equipment that's over on multiple sites. Sometimes it's in multiple countries or in counties, maybe here. And all of them are via the business itself, typically connected to each other secondhand. You know, they've all got some sort of connection. They've got GPS tractors or those telematic systems, IoT sensors. You need to know where your $200,000 excavator is at 2 a.m. You know, that's a fair assumption that you need to be aware of these things all the time. But nobody really talks loudly enough about the fact that that connectivity is the massive attack surface. You know, in cybersecurity, we talk about attack surface all the time, and it's a lovely term. But what that means in real terms to real people having to manage it is very variable. So with construction being one of the most targeted sectors on the cybersecurity world, you're looking at that 31% more attacks, excuse me, across the industry. It's pretty straightforward, the reasoning why. So you digitalized quickly, and then typically, not just you, but any industry that digitalizes quickly, security ends up being at least one or two steps behind that. And you're rolling that kind of stuff out retrospectively. So like putting a smart lock on your front door, but leaving the front window wide open. You know, that's the kind of sense that it makes. It's easy for me to say that I work in the industry, but you also need to be able to get those things moving fast. And if we look at IoT specifically with the sensors and trackers that are on the equipment and the fact that with the 300 million vulnerable, it's, you know, it's a challenge. It's not easy to do. Some of the other things to wear that I haven't actually put on this statistic wise as well. So I've taken 3 statistics from a 2025 report that tell a really clear story around the construction industry and how it sits with regard to cyber risk now. So one of them is that 45% of construction firms have been hit by ransomware in 2025. That's nearly half of the construction firms there have been hit by some level of ransomware in 2025. And my initial reaction to that is don't panic. If you look at all of the industries, the rate of ransomware hits is way higher than anybody actually thinks it is. And it's not because everybody's doing something wrong. It's because some of them are massive hits, some of them are little hits, some of them affect one person, some of them affect the whole company. They all count. It's being aware that it's possible and accepting the inevitability that something like this is going to happen and having a plan in place that's really key to recovering from it. So it's not always just a case of now my email's down. It could be the fleet management system is offline or the site access controls aren't working properly. You need to make sure that you've got a plan in place for what to do if those kind of things happen. The old pen and paper ruses, such as is how we would talk about, like, what do you do if everything goes offline? In the same way we've considered how do we keep businesses running during COVID, you're thinking about how do we keep the business running when these kind of things happen. So like if your project management tools were encrypted and inaccessible mid-build, then what? If, you know, the operational knock-on for that kind of stuff is massive and the recovery time is typically weeks, not days. So having the business continuity plan in place is huge for this, and having the fastest identifying a problem as quickly as possible is also huge. It's going to reduce your costs massively. And another stat, 75% of the IoT vulnerabilities on construction sites that are unpatched. Like we talked about that already. You're talking about 3/4 of the site, the devices in the site having known security flaws that haven't been fixed. Because we're seeing a trend up in the attacks in the construction industry, that's concerning. If they were always, like, they weren't always the first target, but with anyone that's attacking and ultimately looking to cause havoc or get money, they're going to go for the easiest thing possible. So if 3/4 of the devices are unpatched, that's a relatively easy target there. And it tends to get deprioritized, usually because whoever is managing it is also managing something else, or maybe they're the ones that are managing the actual construction project, which of course is a very human response to something like that. But it's a gap that needs awareness of it, knowing that it's there, knowing the size of it. That's half the battle when it comes to cybersecurity. Ignoring it isn't going to help ever. And then the third stat that I want to share then that's not on this screen is that the average cost of a breach in the construction industry is 4.35 million. Now, obviously, that scales again depending on the size of the organization, but even if it's a fraction of that, for an SME, you're talking about something that can genuinely threaten the viability of a business. And that figure includes things like response costs, downtime, reputational damage, regulatory fines, everything, not just the business being out of action, all of the getting things back afterwards and recovering from it then as well. So what those stats are telling us really is that the old way of managing security, being reactive, having manual ways of managing it, or whoever has time for it, isn't something that's fit for purpose anymore. That the complexity and the speed of the modern attacks now has outpaced what any human team can handle all by themselves, which is why automation and AI were introduced to solve this. So let's talk about how that is. Here, 1 second. Here we go. So this slide, it's not very exciting, but it's probably my favorite with regards to what we talk about. So I'm of course biased. I work in Tynes, we do automation, but I chose somewhere that does something that makes sense to me as opposed to just a job. So what we're talking about here is AI powered automation. So at the beginning I said use it, don't use it. You can have these like fixed responses to things. You can choose to have AI interject where you want it to, or you can have it take over the whole thing depending on what your need is as a business from there. So what does that look like in a construction security context? Because when people hear AI and automation together, the reaction is often like that sounds really expensive, or that sounds really complicated, or if you're a team member, like, is that going to replace me in my job, or is that replacing my team? And the answer in all those instances is no in this case. I'm going to walk you through the 4 points that are on the screen. When we come to automating the IoT alerts and GPS trackers, right? The trackers are already generating data constantly, all the time. And the problem is that right now, someone has to be watching that data. Or maybe you get an alert and nobody's able to like respond to it till the morning. You don't have somebody maybe on 24-hour cover that's got access to those alerts. But if you use something like automation, you set those rules in advance. So let's say a machine moves outside of a geofence that you've set and it does it after hours. It's a pretty big red flag. So if you have a workflow in place that is monitoring that information that's coming in from your GPS tracking system, what it can do is fire a notification to somebody who's on call immediately to say this piece of equipment has moved out of where it's supposed to be stored overnight, investigate, find out what's happening. Maybe it is Joe Blogs who's moving it for a legit reason and forgot to tell somebody, but you're better off finding that out than finding out that your GPS has been disabled and you don't know where your kit is then at what hour of the morning. That way no actual human being has to be stuck to a dashboard at midnight or 2 a.m. They just get the notification when it matters. And then you've got nicely rested people working for you on your 9 to 5 then from there. And the AI detecting anomalies in the equipment data. So this is where you see the AI side of it get really, really powerful. You can use your AI to baseline what normal looks like for you. And normal for you, if you're part of a $1 billion company, or normal for you as an SME might be different. But you define what normal looks like for each piece of equipment that you have, and then flag it when something deviates from that normal. So maybe it's unusual engine behavior, maybe it's unusual location patterns, access at really weird hours. They're pretty obvious ones that everybody might think they're all kind of abnormal. But maybe you work different hours to another company, so your hours will change. But once you know what the bar is for you, and then you can put rules in, you can automate rules and trigger whatever you want to happen when those rules are in place. So it might not trigger a traditional rule-based alert, but these are things that are genuinely suspicious, so maybe you want them looked at 9 o'clock in the morning, maybe they're not urgent. You define all of those things when you've got automation, and you sit down at a time when you can think about it. You're not reactively doing that when you're in a panic and you're trying to figure out what to do. If you sit down ahead of time and you go, in the event that XYZ happens, here's what we would do. And then there's the workflow itself. So typically with workflow, what you'll do is you find the alert, you verify the information, you notify whoever you need to, and then lock it down if that's what's necessary. That's the same across the cybersecurity industry anywhere. Ultimately, it's the same task. We might call them slightly different things depending on the industry. So that's automation in a nutshell. If an alert comes in, it gets automatically verified against any other data sources that you have. So you'll check your systems using the automation or using an individual. Then whoever needs to be notified will be notified about it. That could be via Slack, via email, via text message. And then if it's serious enough, you could lock down or isolate the device that has caused the trigger. And all of this can happen in the space of a few seconds, often when somebody is asleep. and nobody has to manually coordinate those things. And at least then you can have peace of mind that you are going to be made aware when something goes amiss. And then the last thing is reducing the response time from hours to minutes. So in security, in any industry, time is everything. So the longer any threat goes unaddressed, then the worse the outcome is absolutely going to be. Automation can close that window drastically. It can make it something that literally only happens within a couple of minutes and you're done and dusted. So the important thing that I want you to take from this particular slide is that it's not magic and it's not replacement for the team. It's a force multiplier. And I think James actually talked about that as well in his it being a multiplier. It handles the volume of information coming in an efficient way so that all the things that matter then go in front of your team and you can make the actual human real life decisions about what it is that you need to do next. And they can focus on the decisions that really need the human judgment then from there. So I said I was going to talk about a case study. I'm going to give you an ideal, which is the one I refer to as firm X, and then I'm going to give you an example of something that's actually happened in the real world. So firm X is the ideal as such. We're going to keep it anonymous. The scenario here is very real and is representative of what's been seen across the industry. So let's say firm X is operating at scale. They've got 50 sites, which is over 200 machines across all of these different sites. And if you've ever tried to manually track the security of over 200 pieces of equipment across 50 locations, then you know stress. And it doesn't even matter, if you're not in the construction industry and you're talking about laptops, iPads and phones, that's in just a traditional tech sense, that's hard enough without making it different kinds of kit then too. So typically something will fall through the gap, and it's always at the worst time possible when these kind of things do. So what this particular case study would do then is build a connected workflow that runs across all of the infrastructure automatically. So IoT sensors on the equipment feed data in real time. That data hits a SIEM, so you've got the security information and event management system, where it gets analyzed for where you've got red flags, what you've identified as something that needs to be looked at. If something looks off, then an automated alert will go to Slack or email or SMS straight to the people who need to know about it. And then depending on the severity, the workflow can trigger a remote response if you want it to, or you can have your human step in at this point and decide what to do next. Many people go for the automated response for the high value equipment because they would rather have John not able to use the kit for 5 minutes when he calls in and says, what's happening here, than risk the kit being stolen or taken somewhere else. So the results of doing something like this, and I've used the statistics I'm using here are based on what we've seen people use in industry already. So we see a reduction of 65% on security incidents when people put automation in place because the response time is so much faster. So it's not a marginal improvement, that's a significant fundamental change in the security posture of the organization. We see a 40% reduction in equipment downtime because if you catch that issue early, whether it's a cyber threat or an attempted theft or an equipment anomaly, then you get to intervene before you're in a full shutdown situation. And then typically what we see with those kind of stats is people recoup their return on their investment within just as short as 3 months. Excuse me. So for any company that's operating at scale, then the cost of the implementation was far outweighed by the savings in a single quarter. So I want to ground it further with this real world example that I've promised you, which would show the detection layer of this kind of solution when it works brilliantly in practice. So there's a group called the John Holland Group, which is a big engineering group and contracting firm that operates across Australia and New Zealand. I purposely picked one that was outside of Ireland just so that you can Google it and look into it, but I wasn't going to cherry pick anybody here. They had a specific and really costly problem that they were faced with, which was tracking spoil removal. I found this fascinating, being that I've never, I don't do the on the ground. But their challenge was that they needed to make sure that excavated materials were being dumped in the right approved locations and not just wherever was most convenient for any driver at the end of a long shift. So manual logging was failing them entirely. It was, tedious. It was inaccurate. It was impossible to enforce it in scale across all the heavy machinery that they have across all the multiple sites. So what they developed then was an IoT asset tracker. So it's a rugged battery-powered GPS device that's mounted directly onto the machines. They combine that then with geofencing rules. So when a machine tipped its load, the device automatically logged the exact location, then checked it against approved zones, and then flagged any unauthorized dumping instantly. So there was no manual forms, no chase-up calls, no arguments. It was all automated compliance running in real time. And that would mean that that notification would go to whoever the site manager is, who gets on the phone to John and is going, what are you doing? Take that back out again and put it where it's supposed to be. So you're not even delayed in the recovery of something like that. So that's exactly the kind of point I think that I wanted to leave with you, is that John Holland had the IoT detection layer. Firm X in the example here has the automated response layer. And if you connect both of them, where you have the sensors that are feeding the live data into an automation platform that knows what to do with it, then you get this really powerful response to it. You get visibility, instant response, and a security posture that doesn't depend on someone being awake at 2 o'clock in the morning. So that to me is what the software innovation really looks like when it comes to construction. It's a real practical technology that solves a real problem at scale with measurable results. And that's me. So I'm happy to, I'll stop sharing the screen now, and I guess we'll get to the questions then when Jamie says we can. Thank you.
Thanks, Jenny. That's very good. In there, so yeah, shocking statistics in terms of didn't realize how much cyber attacks there are on construction firms, but also the actual cost. I mean, 4.3 million being the average cost of the breach in security and construction is a big number. It's not yeah. So
Yeah, and in my experience, nobody's spending that on any single tool. Like, so when you weigh one against the other, it makes sense. That actually that industry across many versus other industries is probably the easiest one to see the sense in implementation, as opposed to other industries where you're talking lower value things. Like everything that you have is expensive. Everything.
yeah.
So
Yeah, not just what we have, but also what we build as well. So, I mean, you talk about
yeah,
security in terms of in the construction phase, but also we are building assets that are going to be in operation for, potentially, well, decades, but potentially hundreds of years in there. So it's a big responsibility to,
true.
build safely, but also to build things that are going to be fit for purpose and operate effectively, efficiently, and safely in future. Okay,
Yes.
so we'll open up to more formal questions. So if anyone has any questions.